Hello, I chose again to do the code, and here we can see, so for this random generated matrix, we get the triangulated one, and we also can see the solution and the time that it took the machine. So here we have the 50 by 51. We can see the triangulated matrix and how much time it took, and we can see this for all the algorithms that I'm going to show the time of each one. Now that we have seen how it prints, to make it more simple, we can ignore the prints and we get the times. So what we can notice is that for smaller matrices, the times are getting somehow worse, but when working with really big matrices, the forward 2 loop and the forward 1 loop is really good. So the forward 3 loops function is what we have seen in class. Then the forward 2 loops, to get rid of 1 4, what I have done is to make this but more compact, so updating the row at once. And for the forward 1 loop, first of all, as always, we get the pivot, we normalize the row, and here we treat each element as a submatrix. So this is a submatrix, this is also submatrix, and this is also submatrix. So we can apply the main idea of making zeros the subpivots all at once. So this function that is named block lets you choose which submatrix you can get from this matrix. So here we specify the starting row, here the starting column, here the ending row, and here the ending column. So the first one, we want to change all the elements that are in the rows below the pivot. So this starts at the next row of the pivot. It starts at the same column as the pivot, but it gets all the rows and all the columns. Then we get this submatrix that is all the subpivots. Here we specify, well, we put the number 1 to get only the first column, that is the subpivot column, and then we get the elements in the row of the pivot. So when we multiply those, we get that the elements in this multiplication of matrices, the elements that are in the subpivot position are the same as this matrix. So when we subtract, what happens is that the elements that are the subpivots are equal to 0, and this is done for every pivot that we can.